Thanks, Sam, and thanks everyone for watching this webinar on troubleshooting BMC Helix ITSM performance issues without enabling logs. The agenda today will be a discussion of why do you want to troubleshoot without logs. We'll look at some performance issue types, what tools are available from BMC, performance monitoring strategies, identifying the issue, common resolutions, and we'll provide some references so you can do more research on your own after the webinar. So why no logs? Well, typically, logs weren't enabled when the problem occurred, and we prefer to investigate the problem now rather than enable the logs and wait for a recurrence of the problem to happen. Turning on the logs may impact performance. Quite often, we say that it's okay to enable the logs because it shouldn't significantly impact performance. But when you're already dealing with a performance issue, the added stress of writing out a bunch of logs may actually impact performance. The logs do impact space and time to enable and collect the logs. They definitely impact space on the drive. So depending on your environment, the logs may grow extremely fast, and now you have to consider whether or not you even have space for the logs. In a container environment, logs are generally not persistent. So if you restart a pod, you're going to lose your logs anyway. So in those environments, you can't guarantee that you're going to have the logs when you need them. Also, there is some coordination effort to enable, gather, and get the logs to the person that's going to be reviewing them. There are times when logs are essential, and so I'm not saying that you should never enable logs. There's times when you need the logs to be able to identify a root cause and solve the problem. Today, I want to show you how you can troubleshoot performance issues even if you haven't enabled any logs. Now let's look at some of the common types of performance issues that you're likely to run into. You may run into issues with your environment. This includes OS tuning, such as kernel tuning parameters, swap space, page file size, and more. This could include resource issues such as inadequate CPU or memory. It could also include database server tuning, which could again go back to resources or any other of the many settings that the database vendors allow you to use to configure the database. I recently gave a webinar on data management. This is a common cause of performance issues since it could make the database have to work harder or cause the end users to have to wade through a lot more data than what they actually need. More specific to ITSM is the ARSystem configuration. Since it uses Java, it's important not only to have enough memory resources on the OS, but that the Java heap be configured properly as well. There are many other configurations in ARSystem that can affect performance. BMC provides a best practice configuration guide in the online documentation to help with this. At the end of the presentation, I provided a link to that documentation so you can look into it further. Now, even more specific to ITSM are the application performance issues. These types of issues are often specific to a particular action or feature within the application. Workflow can be a major source of performance issues. Each piece of workflow associated with an action has some effect on the performance of that action, even if it's very minor. One common cause of performance issues with workflow is when a filter calls out to something external, such as a web service or a REST API call, a run process command, or a set fields action with the $process $, or it calls out to a plugin such as a vendor form or AR filter plugin. Because the workflow is calling something external, there's the possibility that that piece of workflow could take extra time to complete it. Workflow can be designed to push data to another form. This can lead to a single workflow action pushing data to many thousands of records on another form, which can take a bit of time to complete and cause a performance issue. Workflow can perform queries, such as when trying to identify which data to pull in from a different form in a set fields action. If this query is not efficient, it could impact performance. And it's very likely that there are many queries that are going on with all the different workflow in a single transaction. Query design is a big contributor to performance issues. Users performing ad hoc queries that are not efficient are pretty common. End users don't always know how to create an efficient query, but they still need to pull back the data, so they do it anyway. A related issue is when a user performs a fairly efficient query, but then workflow that fires on search modifies the query and makes it less efficient. External qualifications are queries that are built with workflow and then used in table fields or other workflow. Since workflow creates the qualification, it doesn't always create the most efficient query, and then that could also cause a performance issue. Lastly, Row-level security, which I'm going to actually go into more in a later slide, can add a lot of complexity to an otherwise efficient query. So row-level security can sometimes make a query less efficient. All of these common issue types are things you need to consider when you're troubleshooting performance. And you can imagine that it takes a number of tools to look into all these different areas. Today we're focusing on performance issues within the ARSystem rather than looking at the OS, database, resources, etc. So let's look at some of the tools that BMC provides to help you do your investigation into performance issues. Server Statistics Longest API in SQL is a feature that records all the longest APIs in SQLs in memory and then pushes it to a form so that you can review it. The ARException Log is a log that is always enabled. It records any SQL API that ended up with a client timeout. It also can optionally record any of the Server Statistics longest APIs in SQLs. ARSystem RLS Auto Discovery is a form that automatically keeps track of any form that could benefit from using the Subquery row-level security option. Starting in 21.305, AR Server will automatically time out threads when the client times out. This prevents APIs and SQLs from continuing on after the client has already been disconnected. Two new JDBC timeout parameters have been added as well in 21.305 that allow you more control over very long SQL operations. A useful strategy to troubleshoot performance issues is to enable the performance monitoring that's available through the Server Statistics Longest API in SQL feature. You can use the results to identify likely performance problems and identify the possible causes. This feature is accessed through the Remedy or ARSystem Management Console under the Logs option. Here you can perform the configuration as well as the monitoring. The console provides two table fields to view the data as well as direct access links to search the data directly. Now let's look how to configure this feature. On the configuration page, you'll see the applicable to. We usually want to set this to all servers. If we're going to monitor performance on one server, we probably want to monitor it on all the servers. The number of saved operations is the number of operations that we want to store in memory. We don't expect this to be a large number because it's only going to be the number of operations that have surpassed the minimum elapsed time that we'll set in a moment. So 100 saved operations is a good place to start with. The autosave and purge interval is in minutes, and this tells how often to write the data from the memory to the two forms, the Server Statistics Longest APIs and the Server Statistics Longest SQLs. 5 minutes is usually a good place to start with this setting. The minimum elapsed time is in milliseconds, and this is used to look for abnormal activities. Most APIs and SQLs are probably under 20 seconds. So if we start with a number like 20,000 milliseconds, that's a good place to find any APIs and SQLs that aren't quite normal. The Enable Exception Logging option writes to the ARException Log any SQLs or APIs that pass the minimum elapsed time threshold. We expect this to be in minimal writes and can be left on because it's based on the minimum elapsed time. Once I've configured the Server Statistics Longest APIs and SQLs, the data that it collects can then be viewed in either the ARException Log or in the Longest API in SQL forms. The Server Statistics screen on the lower half shows two table fields that make it real easy to monitor the data and see which data has been collected. In the Longest API table, I can see the command that was issued, the specific API. I can see some parameters when it's relevant. Often this is the form name in question. For example, the AR get list entry of fields always runs against a form and it lists the specific form name here. Other API calls don't list a form or have other parameters and they'll be blank. The elapsed time is in milliseconds, so you can see in the first row, the AR get multiple active links took 473 seconds to complete. Provides the username, the specific server that this ran against in a server group. The status tells us whether or not this information was collected automatically using the auto save and purge, or if it was collected on demand by selecting the option I just showed on the prior page. Also, it shows the start time, so we can look at this data and we can look at patterns. For example, if we saw several API calls that took a long time at a very specific period of time, that might tell us a pattern about that time. We can also see patterns based on users or server names, etc. Now let's look at the longest SQL command. This provides some information about where the SQL call came from. For example, if it came from a specific API call or if it was an internal SQL, etc. And then it often provides the SQL command. It doesn't always provide the SQL command. If the SQL call was extremely long, it may not show up here, and you may have to actually open up the record to see the exact SQL command. But in many cases, the SQL command that ran will show at least a portion of it here. The elapsed time again is in milliseconds, so in my test system here, at the time I ran this, I didn't have any really long running SQLs. Again, we see the username, the server name, the status, and the start time. So all this information here at a glance allows you to get a quick look at the performance of your system and also start troubleshooting any performance issues that showed up. Let's take another look at these two table fields and see what we can learn from them. You want to look for long activities, but you also want to look for patterns. The hope is that if you fix something, it'll have a positive effects on the largest audience. In this example, we can see a pattern with the get list entries running on the ARSystem email messages form. This occurs over multiple days, as you can see in the timestamp, so it's not a one-time event. This is probably something that we can look at. Maybe we need to do some tuning with the email engine. We also see a short pattern with the demo user performing a query on the CHG change interface create form. Since it only shows up twice and with the same user, this could simply be a user performing a bad ad hoc query. We can see the same event is recorded in both the API table and the SQL table. If I double click on the SQL table, I can see the full SQL statement, and I can see that the user was performing a search with a leading wildcard, which can't use an index. So this is the case where an end user is performing an inefficient ad hoc query. We'll look at more examples shortly. Now I want to look at another strategy using the ARException log. I mentioned the ARException log is always enabled. The one thing that isn't always enabled is storing the longest API and SQL information into that log. So once you've enabled the ARException option on the longest API and SQL page, you also get that additional information. So you should go ahead and do that. As I mentioned, it's not a lot of information being written to the log, so that usually doesn't cause a concern with adding additional performance issues. So we'll use this log to identify performance problems and patterns within the log, and then try to identify possible causes. The ARException log logs any client timeouts, and any client timeouts are too long. For example, if you're saving a record, the timeout is 2 minutes. If your client timed out after 2 minutes, that's too long, so that's something to troubleshoot. The log also logs any actions or APIs or SQLs that exceeded the thresholds that you set on the server statistics page, and any of those should be checked as well. So we're going to use the log and look for those timeouts, those items that exceeded the threshold, and we're going to look for patterns and see if we can find a performance issue that we need to start troubleshooting. It's possible that many issues that you'll see in this log weren't even reported. So some users might click on something and time out and never tell you about it. You'll see that here, and it gives you a way to identify problems that you may not have known otherwise. Now here's an example of a couple snippets from an ARException log. You'll see in the first example, API operation did not complete prior to the client timeout. So in this case, it was a VER call. A VER call is just to verify user. When a user logs in, this API call gets run. And this API call took 1,609 seconds to run. So that's something that's really bad. It's possible that the user never reported it. Maybe they immediately tried logging in again. Now this client would have timed out probably after a minute or two. So the API ran far longer than the user waited. In other words, a thread was being tied up even though the client had already disappeared. Something like this might be a plugin issue. If you're using RSSO or Area LDAP or something, then the verify user might be going out to some external mechanism trying to authenticate, and that might be what's causing this issue. Again, it's something for you to look at because it is taking time. The second example is an API operation elapsed time exceeded the configured threshold. So this again is the threshold that you configured for the longest APIs and SQLs. And in this case, it only took 52 seconds, which is still quite long, but the important thing was it was past the threshold that I set. And in this case, it was a query, a get list entry with fields on a schema called SMT Union Smart IT Ticket Console. And some of you may know the from Palm Pilot means that this was a Smart IT client. So this gives me the API call that took a long amount of time and gives me something to focus on for troubleshooting performance. In the last example, I have a SQL operation that surpassed the configured threshold. In this case, the SQL took 212 seconds. I can take a quick glance at the select statement and see if there's anything that's obviously ugly about it, or I can start looking at patterns and try to find out if there's a theme going on. Quite often when you're looking at this log, you don't necessarily want to troubleshoot every single item that failed. What you're trying to do is find the important items, things that are affecting multiple people or might be affecting the server in general. For example, in the first VER call, it's possible that that was slow because there was a plugin issue. And if there was a plugin issue, it's possible that plugin issue is also causing other performance issues. Maybe there's many AR verify users going on that are all slow. So look for patterns, try to identify the important items in this log so that you can troubleshoot the important ones and keep your system running smoothly. The next strategy I want to focus on is configuring row-level security. You can monitor row-level security usage by viewing the ARSystem RLS Auto Discovery form. From there, you can identify any forms that might benefit from changing to the Subquery RLS option. Not all forms will benefit. For example, some forms with a large number of rows and many permissions groups could actually see a performance degradation, but it's generally recommended that you at least test it out for highly active forms that do use row-level security. Once you identify forms that might benefit, you can use Developer Studio to set the row-level security form property to Subquery. What row-level security does is it filters database content based on user-specific roles so that end users only see data that they're entitled to. ARServer does this by adding constraints to the SQL statement as it's being issued. RLS increases the complexity of the SQL statement and sometimes has a negative effect on performance because it's so complex. Over the years, we've developed multiple methods of applying the row-level security to queries. The original RLS method used combined likes, which adds a bunch of likes and or statements to the where clause of the SQL. RLS split was added and was sometimes called the new implementation. It uses a database function to apply the row-level security. Finally, we developed the subquery option, which stores all the access control information in a separate S table and joins that to the user query. Subquery generally fetches results faster than the other two methods. The ARSystem RLS Auto Discovery form is an out-of-the-box form that's enabled by default. It contains a list of queries where RLS was used and it exceeded the threshold limit that's set in the RLS Auto Discovery minimum elapsed time setting. The form also contains the number of times that the RLS query was run on a particular form that crossed that threshold. The default value for that threshold is 5 seconds. So you can see in my example here, I had several queries that were against forms that used RLS, and I can see the count for each of these. So if I highlight the first one that has a count of 8, I can look in the bottom half and see that this query was run against the MyIT service request form. So this form is a candidate for changing the RLS type to subquery. Now, once you've identified a form that you want to use the subquery option on, you'll open up that form in Developer Studio and go to the Definitions tab, navigate to the row-level security fields, and the first thing you want to do is check the Enable Security Table option. When you do this, it will create an S table that stores permission information. And then when the form is being queried, the S table will be joined to the query on the regular data table. After you've done that, you can choose the algorithm of subquery. Once you're done, you'll click OK and then save the form, and ARSystem will go ahead and create the S table, and you can start using the subquery option. The next strategy I want to review with you is to understand the timeout queries from get calls only setting and how to configure it if necessary. This feature is available in 21.305 and later versions, and it's important to understand because it changes the behavior of long-running API and SQL calls. If an API call takes longer than the client timeout, ARServer will cancel the transaction. This frees up the AR server thread instead of having it run for a very long time on an operation where the client has already been disconnected. The default setting for this parameter is false, which will cancel any API call that has passed the client timeout. You can optionally set this to true so that it only cancels GET or query types of operations. You may be aware that some API calls that perform a create or an update operation can return an AR error 92, which says that even though the client timed out, the operation may continue on the server and might complete successfully. But if you leave this setting to false, those transactions will be canceled and won't ever complete successfully. This is generally a pretty rare condition where you'd have a client timed out and you expected that it would complete successfully. But if that's what's going on, if you do have cases where you get that 92 and you really do want those operations to continue, then you would set this parameter to true so that it only cancels the query types of operations and not those save types of operations. The last strategy I want to talk about is fairly minor, but does play a role with performance issues. There are a pair of JDBC timeout settings in 21.305 and later versions that you can use to prevent long database operations from tying up your server. So you should be aware of these and be able to configure them as necessary. The JDBC read timeout allows you to increase or decrease the amount of time that an AR server thread will keep a database connection open during a read operation. The default is 15 minutes, so any read type of operation that lasts for more than 15 minutes will automatically be canceled. It's possible that on something such as a reporting server, you actually might want the 15 minutes or longer, so you can increase this if you need to. The JDBC write timeout is a similar feature, but for write operations, and its default is 30 minutes. The prior feature that I just talked about, where it cancels a transaction after the client timeout, does play a role here. The transactions might already be timing out at a shorter amount of time, so why would you need these two extra JDBC options? Well, there are at least a couple reasons I could think of. One is it's possible that you decided to set the timeout queries from get calls only, that prior setting, to true, and it only affects get settings and doesn't affect any sets or save operations. So in that case, these JDBC settings will give you a way to automatically cancel those queries if they go too long. The second reason is that the timeout queries from get calls only is specific to API calls from end users. But AR server can perform other operations, including escalations, for example, that weren't from an API call. So these JDBC timeout settings give you a way to put an upper limit on any database activity. Now with these tools, you'll be able to identify long APIs and SQLs. When you identify a long API, it's a good practice to see if the API is running long because of a specific long-running SQL statement. You can usually identify the long SQL related to a long-running API in the server statistics forms, or even the ARException log. If you don't see a long-running SQL related to the long-running API, then you probably need to focus on workflow. At this point, you're going to need to enable logging. Most likely, if you were to open up a support ticket, support would tell you to turn on the API SQL and filter logging so you can get the whole picture. If you're concerned about logging affecting performance, you do have the option of using log filtering. You can filter logging based on username, client type, and RPC queue. For example, if you knew that the performance issue was caused by Smart IT clients, you could enable logging for only Smart IT clients. In any case, since you already identified the long API call, and you know that you're looking at workflow, since the SQLs weren't long, then you have a good place to start with. So even though you may have to enable logging, you do have a head start. When identifying the issue, you need to decide which activities are relevant. The server statistics results might show a very long-running query, but it might be that was just a single bad ad hoc query from one user. You might provide some instruction to that user, train them how to do more efficient queries, but that's probably not going to be the cause for your general performance issues or whatever it is that you're looking at right now. Also, there are some API calls that are expected to be long, such as reports or CMDB graph walks and others. So maybe things that you decide not to look at. Unless you're trying to troubleshoot a specific API performed by a single user, you're usually looking for patterns that occurred more than once. Now let's look at an example. Assuming we already set up the server statistics feature with an appropriate minimum elapsed time, we can open up the longest API in SQL page. Check the completed and pending boxes and click on the Save Now to push the data to the forms. If you're looking for general performance issues, you might show data for the last hour or the last day. But if you just reproduced an issue like I did in this example, you can look at just the last 5 minutes. In the API results, I can see that a user did a query, which is the get list entry with fields, on the HPD help desk form, and it took over 40 seconds. This is something I just had the user reproduce. If I look at the SQL results, I can see the SQL statement that corresponds to this query. And I can see that the SQL took a majority of the 40 seconds. So if I can solve the SQL statement, I'll be solving the API issue as well. Since the SQL command column is blank, I assume that it's complex and was too long to show. So I can double click on the row to see it. The full SQL command shows up in the extended data field. At this point, I might want to get a DBA involved. They can look at the execution plan and see if an index would help, or if there's another way to improve the performance of this SQL statement. I can also do some quick analysis of the SQL statement from here. I can see that the where clause is where C101 is like a wildcard. Then we have C60988 is like some value. Now you may recognize the 60988 is a dynamic group ID. This field is used for access control. In fact, if you look at the rest of the where clause, it's just a bunch of liked ors. This is all used for row level security. You may recall a few slides ago when I mentioned the different models of row level security, and liked ors was the original style. Another thing this tells us is that the user was not an administrator. Administrators are not restricted by row level permissions. In fact, one test you could run is to have an administrator perform the same operation and see if it's any faster. It's possible that the row level security qualifications are actually making this SQL statement so complex that an index isn't being used. Usually, if the part of the query that isn't the row level security can use an index, then adding the row level security qualifications doesn't make it any worse, but it's a good thing to test. In this case, the remaining part of the query that isn't the row level security stuff is just a simple wildcard search, which has to return all the rows in the table and won't use an index. So we learned from this analysis that a user performed a very inefficient query that used row level security. We've looked at tools to identify problems, and we've looked at how to identify the underlying cause. Now let's take a short look at what some possible resolutions might be. If you use the longest APIs table to find long-running API calls, you'd find that most of the time you're looking at either a get or a set type of activity. Get API calls are get entry, get list entry with fields, etc. In these query types of APIs, the typical resolution is to make the query run faster. There are a number of ways to do this. The simplest way is to identify a field that is used in the where clause of the SQL statement and make sure that it's indexed. For more complex queries, this might take a DBA, but you'll find that there are many times that you can easily identify a field that gets used a lot in the queries for that form, and it's not indexed. Whether or not a field is indexed, it won't use an index if it returns more than about 5% of the records in the table. This is referred to as selectivity. If the query is not selective, even if there's an index, it won't help. So if you can change the query so that it becomes more selective, this could help it to use an existing index or one that you might add. Depending on how the query was generated, this might not be easy to do. If it was an ad hoc query, then you just need to instruct the end user on how to use fields in their queries that are indexed and make sure that they return less than 5% of the rows. If the query was generated by a workflow, then you may need to look at exactly what the workflow was doing and why it was returning so much data, and whether or not you can modify it to use an indexed field. Set API calls are set entry, create entry, merge entry, and service entry. All of these API calls can and usually do trigger workflow. As I showed earlier, you should look first to see if there were any long-running queries that were occurring as part of the API call, and focus on tuning that. But if there were no long-running SQLs, then you'll likely need to enable SQL, API, and filter logging to do more analysis. You may find that you have a workflow that's calling a plugin. In that case, you may be able to do some configuration to make the plugin respond faster. Another likely possibility is that the workflow is performing one or more push fields actions to other forms. If the push fields qualification matches a large number of records in the target form, then this could easily create a performance issue. A couple of ways to fix this are to make sure that the push fields query is more restrictive so it doesn't match so many records, or to remove some of the unneeded data in the target form if that's possible. Many performance issues end up being on the database side. One reason for that is that most workflow is very fast itself, and the main thing that can make workflow slower is pulling back data or pushing data to the database. If you use the longest SQLs table to identify a long-running SQL, it's a big benefit if you can associate that to a form name, so you have a better idea of what's happening. And I showed you earlier how you can do that using both of the tables together and looking at the timestamps. Once you identify a bad SQL, you can send this to a DBA and get their response on the best course of action, or you can try to review the SQL statement on your own. The things you are looking for are, can it use an index? There are certain rules that the DBA will know about, such as leading wildcards and not equals won't use an index at all, even if you have one. If the query can use an index, does an index exist? If the index exists and the query should use an index, is it selective? In other words, does it return only a small percentage of the records? Again, these are questions that the DBA can help with, but in some cases you can answer them on your own and resolve the issue yourself. It's possible that the SQL statement as is simply can't use an index. In these cases, either you have to allow those queries to take a long time, or you have to change them. Changing them means either instructing the end users on how to perform efficient queries, or modify a workflow that performed the query. If the workflow is out of the box, then it's best to contact support and see if we can make an official change so that the modified query gets into the product. The purpose of this webinar was to provide you tools to solve performance problems if you didn't have logging enabled or if you don't want to enable them. But there are certain limitations on what you can do without logs. Logs provide a complete play-by-play of what the AR server is doing. Without the logs, you're not going to get that full play-by-play, and you're only going to see what one thread is doing at a time. Logs provide more context. Without logs, we only have the specific actions that showed up in our tools. Logs allow us to look at various components such as escalation, archiving, and other things. Without the logs, we really only see APIs and SQLs, so we're very restricted on what we see. So there may be times in troubleshooting that in order to solve it, you simply have to enable logs. Now, in summary, many performance issues can be identified without enabling logging. BMC provides an easy way to monitor performance using the server statistics. This is a tool that you may start using all the time now. It just allows an easy way to monitor your performance. AR Server protects against long APIs tying up threads and causing performance issues starting in 21.3.05. Here are some related resources that you can use to do some more research on your own. There's a link to improving performance by using RLS algorithms. There's a link to gathering statistics using the longest SQLs and APIs. We provided a link to the documentation on JDBC Timeouts. Here's a link to the best practice configuration documentation. And finally, a link to the best FAQ on ARSystem and BMC Helix ITSM performance issues. This FAQ is a good place to start when trying to find knowledge articles that might help you as you're troubleshooting performance issues. And this brings me to the end of my webinar. So please visit the BMC community at community.bmc.com. And if you had a question today that didn't get answered, you can feel free to ask your question to the peer support channel on the communities. Thank you for watching this webinar.